All right, so we finally got a trig one. I've gotten all your messages. So just in case, sine cubed of x is sine of x whole thing cubed. So when we take a derivative, our 3 is going to come down front. So we're going to get 3 sine of x squared cosine of x, or written kind of like mathematicians, 3 sine squared of x cosine of x. All right, so then each of these terms gets a chance to be equal to 0. So if I set this equal to 0, do it up here. 3, actually, I don't even care about the 3, right? We can divide it out. Sine squared of x is equal to 0. This is going to equal 0 whenever sine is equal to 0. So sine is equal to 0 at the origin. It's also equal to 0 at pi. And if we're going backwards in time, it's also equal at negative pi, right? At 0 at all your integer values of pi. 1, 2, 3, 4, 5, 6, 7 pi. Each of those sine is 0. Cosine of x is equal to 0. At the pi over 2's, the odd pi over 2's. So we're going to get a negative 3 pi over 2 because we care about this interval from negative 2 pi. Pi over 2, pi over 2, that's negative. Pi over 2, and then 3 pi over 2. So we have a lot of critical numbers here, right? So kind of written in order, negative 3 pi over 2, negative pi over 2, 0, pi over 2, pi, 3 pi over 2. Yikes. Now, it's not going to be as bad as it seems with all of these critical numbers. All right, so let's break up our number line, right? So I'm going to have a, so we actually kind of look like this, right? Negative 2 pi, positive 2 pi, right? Those are boundaries for us, and they're kind of open intervals, so we should kind of think about them as open. All right, so we have a negative 3 pi over 2. We have a negative pi. We have a negative pi over 2. We got a 0. We got a pi over 2. We got a pi. And we got a 3 pi over 2. Now, a couple of things that are like really nice here. Number one, when we look at our derivative, again, we always want to take a moment, just look at it and see, is anything always going to be positive, or put better, is anything going to be non-negative always? In this case, well, yeah, the 3 is always positive. We don't need to worry about it. And sine squared is always positive. So the only thing that's affecting our table of sines is the cosine. Now, even better, right? So you might be like, ugh, I forgot my unit circle stuff. Well, if you kind of look at the intervals 0 to pi over 2, well, pi over 2 is quadrant 1. So this is just what is cosine doing in quadrant 1? In pi over 2 to pi, this is quadrant 2. This is quadrant 3. This is quadrant 4. We're just looking at the basic kind of quadrants here. So negative 0 to negative pi over 2, right? That'd be if we rotated backwards. That's quadrant 4. Put another way, we're going, repeating what comes before quadrant 1, quadrant 4. We got a quadrant 3, we got a quadrant 2, we got a quadrant 1. All right, so here are our intervals. Now, when we think about just what the cosine does, right? Cosine is positive in 2 quadrants, quadrant 1, quadrant 4. So positive, 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 and cosine is negative everywhere else. Negative, 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 negative. So our function, let's see, where are we positive? Where are we less than 0? So we want to be precise here. Negative 3 pi over 2 to negative pi union negative pi to negative pi over 2, right? We're not decreasing at negative pi because we're 0, we're stopped. We're also doing it from negative pi over 2 to pi. And again, from pi, is it union? From pi to 3 pi over 2. That's where our function is negative, so therefore that's where our function is decreasing. All right, where are we increasing, or where are we positive? From negative 2 pi to negative 3 pi over 2. Then again, union from negative pi over 2 to 0, union 0 to pi over 2, union somewhere else, 3 pi over 2 to 2 pi. So this is where our function is going to be increasing on that interval. All right, so let's see, where do we change signs, right? Positive to negative, right? Increase to decreasing, that's going to be a max. Decreasing to decreasing, right? We're going to go like that, right? That's nothing. Decreasing to increasing, that's going to be a min. Increasing to increasing is going to look like that. That's nothing. Increasing to decreasing, that's a max. Decreasing to decreasing, that's a horizontal line of tangency. Decreasing to increasing, that's a min. So we have a maximum value when x is equal to negative 3 pi over 2. We also have one at pi over 2. We have let's see, a minimum when x is equal to negative pi over 2, and probably another one, positive 3 pi over 2. All right, so to find those values, let's see. All right, so we could plug it into, whatever, sine of 3 pi over 2 negative. All right, so if we find this value, a sine of negative 3 pi over 2 means that we're at basically right there. We're at the positive y-axis, right? We've rotated back to pi over 2. So sine of pi over 2 is going to be 1. If I cube 1, I'm going to get 1. So we're going to get 1 here when I plug in. It's going to be the exact same thing as the sine of pi over 2 cubed. So we're going to get 2 ones. Negative 3 pi over 2 comma 1 and pi over 2 comma 1. Yeah, they're probably negative ones. So if I do negative pi over 2 sine cubed negative pi over 2. So negative pi over 2, I've rotated down to the negative y-axis where sine is negative 1. If I cube negative 1, I'm getting negative 1. And whatever the other value was, probably sine of 3 pi over 2 cubed, same thing, negative 1. So we would get negative pi over 2, negative 1, and 3 pi over 2, negative 1. Those are our minima for the function. You can graph this thing if you want. I think I graphed it earlier. It looks like that, right? So we can see these horizontal lines of tangency, these kind of things that minimums, mountains, things like that. Look at that. We got some answers. There we go. There's a function. There's your answer.